Okay, so on this question, what we're wanting to do is we're wanting to solve a 3 by 3. This is called a 3 by 3. Math and science people call this a 3 by 3 because it's 3 equations with 3 letters. It's called a 3 by 3. And so it says, first off, it says it wants you to, given the system, write it like this and then solve it. What do they mean write it like that? Well, what they mean is just take off these numbers and just put them down. So -6, 2, 9, like that. And then the next number is 2, 2, 2. The next number is -8, -8. And then what number is here? Really a 1, right? There's nothing in front of the z, so it's, you don't put 0, right? Why not 0? Well, what would 0 times z be? That'd be 0. That wouldn't be z, would it? Whereas 1 times z, that's the same as z. So we haven't changed anything when we call it 1 times z. All right, and now and over here go these 3. So -101, 0, and -99. So what did we do? We just changed the format from 3 separate equations with 3 letters to one big matrix equation. Do you see it? This is all one big matrix times, right? See the times dot right here? One big matrix times a what we call a column matrix, has a bunch of letters in it, which equals a number. So in other words, what it's kind of like having a number. Like, what if I had like 7 times x equals 3 or whatever. But it's a matrix equation instead of just a number equation. Does that make sense? We're in the matrix world now. Well, think with me for just a second. How would you solve if you had this equation, 7 times x equals 3? How would you solve for x? You know, right? You would know exactly what to do. What would you do? You would just divide both sides by 7. Boom. Like that, wouldn't you? And the answer would be 3/7. And that's right. That's exactly how you would solve that. When you divide by 7, do you realize what you're doing? You're doing the inverse of multiplying by 7, right? What's up here to begin with is times 7. That x is multiplied by 7. So what's the opposite, the inverse of multiplying by 7? Well, it's dividing by 7. Right, that's why it gets rid of the 7 there. The multiplied 7 cancels when you divide by 7 because that's the inverse. So really, if you think about what we just did, is we did the inverse, right? We did the inverse. So that's what you have to do. You divided by 7, which canceled this out. That's the inverse on both sides. So in the same way, you have to take this whole matrix. It's like a 7, but it's a whole matrix. And you've got to multiply by the inverse on both sides of the equation. Why? Well, that's exactly what we did with the 7. We divided both sides, right? You can't just do one side. If two things are equal, you've got to treat them the same, and then they'll be equal afterwards, right? So I did the inverse of the number. Here I've got to do the inverse of the matrix on both sides. And what will happen? Well, the same thing that happened down here. What does an inverse do? It'll cancel this out, just like this 7 and this 7 canceled out and x was alone. In the same way, this and this whole matrix will cancel out, and you'll have the answer matrix alone. You see that? The answer matrix will be alone. And what will the answer matrix, the x, y, z, just like getting an x alone, it'll equal whatever the inverse is times the matrix that was already over there, which is the -101, 0, minus 99. Are you seeing that? So I'm giving you the theory, and then I'm going to tell you what we're going to do. We're just going to push the buttons. But I want you to understand the theory. That's really what's most important here, is the idea behind what we're doing. Not just a, hey, step 1, step 2, step 3, crank it out, like we do a recipe. Just throw the eggs in and the sugar and the flour, mix it up, throw it in the oven, boom, out come cookies, without understanding all the chemistry involved in the heat and the sugar and the flour and the eggs and the milk, right? I want you to understand here, not like cooking cookies. I want you to understand. So just like we solve 7x equals 3 by doing the inverse, dividing by 7 on both sides to cancel this out and get x alone, likewise, I'm going to get rid of this matrix to get the letter thing alone by doing what? The inverse of this matrix. And we just learned how to find inverses. We're going to do that. We're going to find the inverse of this matrix, because the inverse of the matrix times the matrix itself will cancel out, just like 7 multiplied and 7 divided cancel out. So you do the inverse of the matrix on both sides. It cancels out here, and that gets you the letter matrix alone. On the other side, you have the inverse times this. Inverse times this. You have to be careful. Yeah, let me just leave it at that. So you have to be careful. Well, I would say you got to put the inverse on the left. See, I'm doing the inverse on the left and the inverse on the left on both sides of the equal sign. The inverse is coming into the left on the left side and the left on the right side. It's got to be consistent. It's the left on both sides. So we do. So I did the inverse on the left side and on the left on the right side. Cancels out here. The letters are alone. And over here, it's inverse times the matrix. So basically our answer, XYZ, is going to be the inverse of the original matrix, the inverse times the right side. And that's exactly what I'm telling you in the notes. Let me show you in the notes. I want to give you the theory here. Here it is in the notes. How do you solve 3 equations using matrices? You let A be the 3 by 3, let B be the right side, and then you take the inverse matrix times B with technology on the calculator or on Geogebra, and using technology, you get the answer, and that is XYZ. That's what I just showed, right? I said take the inverse times the matrix on the right. See that? Take the inverse times the matrix on the right. So that's it. So let's do it with technology. So basically with technology, I'm going to take this matrix, I'm going to call it A, or whatever you want to call it, and then I'm going to take A inverse, and I'm going to call the one on the right B. I'm on Geogebra or on TI graphing calculator, I'm going to call the original matrix by the name A. I'm going to call this matrix B, and then I'm just going to take A inverse times B. That'll be the inverse of A inverse times B, and that'll be my answer. Automatically, I'll get all 3 XYZ in one fell swoop. All right, let's do it. So that's the plan. I'm going to put this in, call it A, put this in, call it B, and then my answer is going to be the A inverse times the B, because it's just like solving for X in a normal equation. You just do the inverse on both sides. All right, let's go to the TI graphing calculator and do exactly that. I can find it. There it is. All right, TI graphing calculator. Here we go. First thing is you got to put it in. You got to go second matrix, go over to edit. I'm going to edit matrix A, enter. So I got to put in 3, enter, 3, enter, 3 by 3 matrix. Let's put it in -6. Make sure you use the negative button, which is different than the subtraction. So the negative is at the bottom with the parentheses around it. Negative is on one number. Subtraction goes between 2 numbers. All right, I'm putting in -629, and 2, enter, 2, enter, 2, enter. Bottom row, -8, -8, 1. -8, enter, -8, enter, 1, enter. -8, -8, 1. Okay, every time I hit enter, it saved it. So it's all saved. Matrix A is saved. Second, quit. Now I need to go back into the matrix menu a second time. Go over to edit, and this time go down to B, because you want to put in the information for matrix B, which is the right side. So I'm going to edit B, enter, and B is going to be a 3 by 1. Because remember, you go down first, down 3, 3, enter, 1, enter, sets up a 3 by 1. That my right side matrix was -101, enter, and then 0, enter. I got to type it in 0, enter. There we go. 0, enter, and -99. -99, enter. Every time you hit enter, it saves it. It's got it. It's got it saved. Second, quit. All right, it's got it. Now I just need to call them forth. Go into the matrix menu a third time. I'm going to name matrix A. Here we go. Enter. It calls it forth. Hit the X to the -1 button. That's A inverse. Hit times. And then second matrix. and name B. Go down to B, name B. Enter. There it is. A inverse times B, enter. There it is. There's X, Y, and Z. 3, 8, negative 11. That quick, we've solved a 3 by 3. This is way easier than doing all the work by hand. Remember, we did these by hand in the last section, or a couple sections ago. 3 equations with 3 letters. This is way better, isn't it? There it is, all 3 answers. Let me show you on Geogebra now. On Geogebra. So let me delete this and delete this. All right, so we go A equals Geogebra. You got to use the curly brackets. Curly brackets, so negative 6, comma 2, comma 9. And then go to the next one. 2, 2, 2. Go to the next one. Oops, forgot my comma there. 2, 2, 2. Next one is negative 8, 1. Negative 8, comma negative 8, comma 1. All right, see what I laid out? Each row has its own separate set of curly brackets, commas in between them, curly brackets on the outside of the whole thing, enter. So there it is. There's the matrix A, the left side matrix. Looks perfect. Second one I'm going to call B. B equals, and I'm going to do a column matrix. Now, careful, column matrix, you got to put a curly bracket for each number. You know what I mean? Let me show you. Negative 101 in its own curly bracket, comma, and 0 in its own curly bracket, comma, because it's a whole row. Each one is its own row. Negative 99. See what I've got there? Negative 101, 0, and negative 99 each have to have their own curly bracket separated by commas. Why? Because they're each a row. It goes down. So each one of those is a sideways row by itself, right? Enter. See how it's gotten. If you do it sideways, it won't work. You got to do it this way. All right. And so now what? A to the power, hit shift up arrow, shift 6, inverse, and then right arrow to get down in the main line, times, that's shift 8 with the asterisk, times B, enter. There it is, same answer. 3, 8, negative 11, X, Y, Z. So we solved it using technology. We solved 3 equations with 3 letters using technology, TI graphing calculator or Geogebra, just like that. And so that's how it works. That's how people do it. Getting back to the main original question here. Here we go. So there's our answer, XYZ, XYZ. And so they want you to type in the answer as a matrix on that. I guess, honestly, I don't even remember. Let me go back. What number is this? Number 3? Let me go back to the original question. Number 3. And then what kind of solution do they want? What do they want for X, Y, Z on this one? Well, they want, they just want you, they want it in parentheses. Parentheses X, Y, Z. I see. So there we go. They want it in parentheses. Let me go back and type that in. All this technology switching back and forth here. So yeah, so the final answer, final solution, they want you to say whatever, 3, what was it, 3, 8, negative 11, I think? So the solution is 3, 8, negative, you got to put it in parentheses. That's X, Y, Z, 3, 8, negative 11, like that. Just like that. So in the end, what do you have to do? You got to put this in, call this matrix A, put this in, call this matrix B, and then the answer is just A inverse times B. That quick, and you've got X, Y, and Z. There we go.